Good day, friends. In the last few videos, we applied the idea of pseudo force with the condition that the object remains stationary related to the non-inertial frame of reference. Today, we have a different problem. A cart block system. Again, the top surface of the cart is horizontal and rough. Initially, the block and the cart remain stationary, and then the cart starts with an acceleration of magnitude AC directed to the right. The block has mass m. The force of static friction is not strong enough to keep it stationary relative to this cart. So the block will have an acceleration just directed opposite to the direction of the acceleration of this cart. And the block has an acceleration of magnitude AB directed to the left relative to this cart. Now let's assume that any vector directed to the right is positive and any vector directed to the left relative to this cart is negative. So we put a negative sign for the acceleration of this block. Now let's analyze the different forces acting on this block. The force of gravity acts on this block downward, and it's given by W is equal to the mass of the block multiplied by the acceleration due to the Earth's gravity. The normal force exerted on the block by the surface of the cart is directed upward, and say it is R. This normal force and the force of gravity cancel each other. There is another force, the force of kinetic friction, and let it be Fk. And our objective is to find an expression for this force of kinetic friction acting on this block. The pseudo force experienced by this block is equal to negative mass of the block multiplied by the acceleration of this non-inertial frame of reference AC. The net force acting on this block is given by F net is equal to Fk, the force of kinetic friction, plus pseudo force, and by Newton's second law of motion we know that the net force acting on any object is equal to its mass multiplied by its acceleration minus AB for this block, or Fk, the force of kinetic friction, plus in place of pseudo force F we write minus MAC is equal to minus MAB. Finally, we get the expression Fk is equal to MAC minus AB. Here is the expression for this force of kinetic friction exerted on this block. Now let's find an expression for the coefficient of kinetic friction between this block and the top surface of the cart, and let it be mu k. we have the normal force R is equal to mg, as the normal force exerted on this block by the top surface of the cart cancels or balances the force of gravity. W is equal to mg, thus R equal to mg. Therefore, the coefficient of kinetic friction between the block and the surface of the cart is equal to the force of kinetic friction divided by the normal reaction, or mu k is equal to Fk. In place of Fk, we write this expression m multiplied by AC minus AB divided by mg. Therefore, mu k is equal to AC minus AB by G. This is the expression for the coefficient of kinetic friction between the block and the surface. I think the solution is quite clear. In the next video, we'll have some very interesting physics problems. Thank you.